According to Elon Musk, this is one of his favorite interview questions. You are standing on the surface of the earth. You walk 1 mile south, 1 mile west, and 1 mile north. You end up exactly where you started. Where are you? To answer this question, let's first assume that the earth is a perfect sphere with longitudinal and latitudinal lines. We will then define what north, south, east, and west mean on our perfect earth. North means going toward the North Pole along the lines of longitude. South means going toward the South Pole along the lines of longitude. East means going counterclockwise along the lines of latitude, looking down from the North Pole. Looking down from the North Pole, west means going clockwise along the lines of latitude. A standard answer would be the North Pole. This is because we can travel south by 1 mile, then we travel west by 1 mile. Finally, we travel north by 1 mile, where we will complete an equilateral triangle. Can we do this from the South Pole? Remember that we have to walk toward the south first, so the answer is no, because we cannot walk south from the South Pole. If we were to walk along the longitudinal direction from the South Pole, the only direction we can walk is the north direction, because we will always be walking toward the North Pole from the South Pole. You may now ask, is the North Pole the only starting spot that we can create an equilateral triangle on a sphere? The answer is yes, if we follow the strict definition of traveling along the longitude and latitude. Here I'm showing a counterexample of starting at a spot that's not the North Pole. Another interesting fact is that after we've traveled south by 1 mile from the North Pole, as long as we travel west by some amount, we can always travel north by 1 mile to get back to the North Pole. But is there any other way? A hint that your interviewer may give you is that on a sphere, if we keep on traveling in the east direction, for example, we can complete a circle. To be more specific, if we were to follow a latitudinal line and walk east, we can walk a full circle and still consider ourselves as walking east the whole time. This also applies to walking west. However, this does not apply to walking north or south. Well, how does this hint help us? Now imagine we have a 2D paper. We walk south by 1 mile. Then we walk a circle that's a circumference of 1 mile. We can then walk north by 1 mile to get us back to where we started. The key here is to walk a circle of 1 mile. On a sphere, we need to find a latitudinal line that has a circumference of 1 mile. There are 2 spots that we can find a latitudinal line that has a circumference of 1 mile. The first spot is near the North Pole. If the circle shown is 1 mile in circumference, then its radius is less than 1 mile. If we were to walk 1 mile along a longitudinal line, then we will end up first walking north for X miles, and then walk south for Y miles, to finally get that 1 mile walk, where X plus Y is equal to 1 mile. But we had to walk a full mile south first, as given to us in the problem statement. Let's try the South Pole. Near the South Pole, we can actually have a path that will allow us to walk completely toward the south to that full circle of interest with a distance of 1 mile. For example, after we've walked 1 mile south we can start walking west to complete a full circle. Finally, we can walk back north to where we started. In summary, we have two methods to solve this problem. The first answer is traveling near the North Pole, but the North Pole is all water. So the second answer is traveling near the South Pole. Let me know what you guys think, and feel free to comment below to let me know what problems to cover next. Thank you for watching.